a few really quick points in the context of what Jitendra and Anka and Ashutosh has already said, and what I know Peter will say. And I'm going to argue that to get towards actionable deep learning, deep learning that can act in the world, we really need adaptive deep learning. So Jitendra gave you the history of it. So I won't repeat that. Jitendra also showed you this slide of how deep learning has made a revolution in computer vision. Talk about that. I'll just, and I think we've already heard that where these models work, they work really well. And they work with models that have incredible numbers of parameters in them. And they work in a supervised learning setting, traditionally. And this might worry you a little bit. Does this mean that I need an enormous amount of training data? I have to go out and label millions and millions of points for everything that I'd ever like to do? Well, maybe actually I will get swallowed up by the task of labeling all of the data before I even get anything done. So the good news is that's not what's happening. And one of the things that perhaps was the most interesting and surprising aspect of these models is not that they worked in a brute force sense, but that the models that were learned had some structures that translated and transferred to other tasks in ways that were surprising. And so that's actually the main interest that I have in this area right now, is how do we take models that we learn through this class of techniques and show that you can adapt them or transfer them to new tasks and new domains. And as a nutshell idea, or the essence of this idea is how can you train on one set of data, say I get data from the web, but then I have to test or have my robot act in another world. And we call this a domain adaptation problem, and we've recently been showing ways that deep learning can thrive in this setting as well, and I won't go into detail, but I'll come back to this in a second. So there's lots of ways that deep learning models can adapt to new settings, new tasks, new domains, new modalities, and we have a slew of papers that I'll be happy to talk to you. Today, though, the focus is on action. How can they adapt to action or learn in an action setting? I'm sure Peter will mention our work with Sergey Levine and Chelsea Finn on Visuo-Motor policy learning. And as Anka mentioned, the key challenge here is as we shift from a classic supervised learning task to a reinforcement learning task, you can't actually just say, I have an enormous training set and I can just learn from that. You have to have complicated, interesting ways to generate your training data, and that's what this work has been about. And going forward, I think combining the ideas of domain adaptation in this setting, I'm quite excited about the idea of can I train in simulation? Can I just train from a CAD-CAM model of the world? Either to recognize objects or to actually execute a control policy that might fly through the environment. So we've seen recently evidence from other labs. Several groups have been showing you can actually train from synthetic models and still do recognition, not as well as sort of ground truth labeled data, but good enough, and probably good enough to train robotic policies. So I think that's kind of where I think we're going to be going in the next 6 to 12 months, and I look forward to those results. So training purely from simulation, but adapting to the real world and executing in the real world. Last, I want to put a plug in for a new initiative between Citrus and California Path. Ken and I are leading this. We're calling it the Berkeley Deep Drive Industrial Consortium, and we already have a critical mass of industrial partners to launch later this month. So stay tuned for an announcement on this, and if you're interested in more information about it, either as a PI or as a sponsor, please come talk to Ken or myself. Thank you very much.